Well, we don't need to become too didactic here, but you probably remember this from last year. Darwin's theory is not a single theory, okay? It is a series of facts and inferences that point in one direction. And this is something that our creationist friends tend to forget. They think that if you pull one brick out of the whole structure, it's falsified. And that's not true with Darwinian thinking. And of course, Darwin wrote this 150 years ago. Okay? And he could not have got everything right, and he could not have understood absolutely everything, of course. Well, Darwin observed with his own eyes that species produce many more offspring than can survive. Okay? And anybody who goes hunting or spends time on the beach, we know this is true. Natural variation within and between populations. There's some morphological variation, just like there is with us. Maybe only one of us could become a pro basketball player because the rest of us don't have the right mutation that allows you to be super tall and super coordinated. Variation is inherited by the descendants. Okay, he didn't know how, of course, but it was. The environment is a struggle for existence. Okay, it is. There's no question about it. There's predation, there's disease, there's competition, sexual competition, and so forth. So there's going to be some retention of favorable traits that allow a descendant to be a little more better adapted, and this is what's called natural selection. And through many generations, you end up with a new species, potentially. And in other words, species are not fixed. Okay, they can change into new species. That's the basics of Darwin. And the whole book is really an explanation for why those make sense. Okay, and we don't need to talk about it now, but all of that is backed up with data, okay, real observations. Well, Darwin by now is a bona fide paleontologist. He's admired greatly. Okay, the barnacle work was stuff that he did that was real paleo. Okay, and then he helped many other people with all the stuff that he brought back. So he was quite aware that paleo was helpful for him, paleontology, because the fossil record shows evolutionary change, different species. Okay, it is the record of the history of life on Earth, and he had even by the mid-1800s, they had a pretty good idea of the overall picture. And this is a very important inference that Darwin was the first to make, is that if there's so much evolutionary change, then the Earth must be much older than people had thought. Lyell was sure that it was old because Lyell had a feeling that change was relatively gradual, and for all the things that you could see and all the strata and the rock types and the old rocks and the old fossils, it must be much older. Physicists, of course, because they know everything, they didn't buy this at all. And of course, 50 years later, there's the famous story of, what's his name?
Lord Kelvin?
Yeah, Lord Kelvin of Largs, which was the name of the ship my dad sailed in during the war, who calculated a certain age of the Earth, but based on a wrong premise. And it's either Rutherford or Kelvin said that, and I've seen both in the literature, that if it's not physics, it's just damn collecting. And that's unfortunately a bad attitude. Many people still think that way, if they're physicists. I think I offended somebody. Well, but Darwin had trouble with the fossil record still, okay? Is that fossils are nature's experiment already done. Nature did the experiment, and the paleontologist is there to try to figure out what Mother Nature did. Is there a religious group that believes in Mother Nature? Some kind of great, well, maybe the Gaia mentality. Yeah, the Gaia. Oh, well, anyway, fossils cannot speak to the mechanism of evolutionary change. So Darwin's theory about natural selection is not based on fossils. It can't be. So he even wrote a chapter where it's called On the Imperfection of the Geological Record. And I don't know if we need to read this out, but he is saying that where are all the intermediate steps if evolution takes place the way he sees it, is the gradual accumulation of small changes. Each one of those changes improves the adaptation of that species or that population. Darwin thought in terms of populations that he was the first one to do that. Those populations were better and better adapted to the environment, or if the environment changed, they were better adapted to those changes. Where are all those intermediate steps? Well, he couldn't find them. The fossil record of the day, 1859, did not show that pattern. So he even said, perhaps this is the most obvious and gravest objection against my theory. Now, I just told you that his theory was not a monolithic theory. It's really only part of it, okay? The consequence of his theory, part of his theory. Other parts are fine, okay? But the lack of these gradual changes in the rock record does not support this part of the theory. So he says it must be because of the extreme imperfection of the fossil record, the geological record. And you know what? To some extent, he may be right. Because the fossil record is showing the sudden appearance of species and groups of related species. They have abrupt differences. Okay? They do not show tiny little incremental changes. He argued that fossiliferous stratigraphic units, okay, there is not that many of them, ultimately, and they are intermittent. Okay? And he even argued, again, here we go back to sea level again. Sea level change, rise and falls. When it rises, you can deposit some sediments. When it falls, those guys get, sediments are eroded, and you lose information. Okay? You lose information. He also said that most of the world was not yet explored for fossils. He's right. And it is true. Back in those days, the fossil record really was imperfect. So what did people do? Well, Huxley, Thomas Henry Huxley, whom we all admire as Darwin's bulldog, a great admirer of Darwin, and as you know, he was sort of like kind of a stooge for him in the early days. Huxley, by the way, applied for a job at University of Toronto in about the 1860s. I know it's okay. It could have been just before Darwin, actually, Darwin's book. And he didn't get the job because, you know, the administrators, they were, of course, it was nepotism, and they hired a local boy who was the son of a premier or something like this. I forget the exact story, but it's public knowledge. The guy didn't do anything at all. Deadwood, total deadwood. But just think if Huxley had come to Canada in the 1850s and helped start the University of Toronto, was called the Department of Mineralogy in those days. Who would have saved Darwin from Bishop Wilberforce? You know, we don't know. It's interesting. But Huxley carried on being a great zoologist, as we all know, and he came to the States to give a talk in 1876. He went and spoke to Marsh, who was a vertebrate paleontologist, who told him about the fossil horse record of the interior United States. Okay, these are the older ones and these are the younger ones, and they put it together as if it were gradual change. Okay, they took the data and they fit it into a preconceived Darwinian notion, gradual change. Okay, the horse started out here as a kind of a gracile, three-toed horse, you know, and then as when time went on, it became a big horse, you know, and clunky and not nearly as nice as not like a pony. These guys were more like ponies. Well, this attitude persisted through paleontology up until really the 1970s, and we'll come to that in a minute. So here's Matthews, again, another famous vertebrate paleontologist, and here is a diagram that he put together from the same sort of data. Eohippus, the old horse, Eocene, coming up through Equus, the young horse, and of course, in North America, the horses went extinct, but they had to be brought back, if you like, from Europe. And again, the idea is this gradual change, slow change. This is Darwin's thinking still influencing other future generations who don't stop and say, wait a minute, this is not what my specimens are telling. But you know, scientists are human and they make lots of mistakes.